Hi guys, my name is ClintonH. I am a student at Full Sail University. I'm going there to get my bachelor's degree in game design. The month is October and my instructor's name is Mr. Donald Johnson. Also, I apologize for the demo mode watermark going across the screen because I'm using ScreenFlow in its free version that is there. So, let's go ahead and get started. The topic we're going to be talking about is gravity. Something that happens everywhere, whether it's on the sun, moon, other planets, asteroids, comets, just about everything in the solar system here on Earth, and it all fluctuates. But why does it fluctuate? As you can see, each planet is close to the sun. There's some that are closer, there's some that are farther away, some have more moons. All of these take into account how close it is to the sun, how close it is to other planets, how fast it's spinning, how many moons it has. Everything is affecting the gravity of each of these planets, as well as their size, of course. That's why Jupiter has the largest gravitational pull in our solar system. And, of course, it varies on and on and on, and I could explain all this is why, but I want to go ahead and get started on what I am so excited to be talking to you guys about today. That one subject is gravity on other planets, not just here on Earth and on the moon. In this video, you can see on the left-hand side is me on Earth doing the same thing that Neil Armstrong did on the moon. As you saw in the video, I did it a lot faster, but wasn't going as high as he was. This is because the gravitational difference is about 1/6 on the moon compared to Earth. Now, I decided that I wanted to test this in video games as well. So I went ahead and hopped on Destiny to see if it matched and timed how long it took me to jump up and fall right back down on the Earth, Moon, and Venus. Of course, if you know, there is Mars, but I didn't have the time to do this. So all these numbers look relatively realistic, 1.09, 1.33, and 1.24. But whenever we come over here to look at the gravitational pull, you can tell that it's way skewed. We have a 9.8 meters per second squared on Earth, but on the moon, it's a 1.6 meters per second squared. So they should be far more than a few tens of milliseconds short. And Venus is the only one that should actually even be close, but it should still differ by at least a good 20 milliseconds. I of course, did not do the exact math. But the jump is not the only thing that was askew. Also, the grenade test. I decided to throw the grenade and then walk the distance, timing the distance to see how far it was, as I do not actually have measuring sticks in the game. And it took me approximately the same amount of time from where I was standing to where the grenade had landed. This meaning that the gravity was the same on all three locations. No difference. On the moon, the grenade would have gone much further, as there is no air resistance, and the pull of the grenade back to the surface would be far less than on Earth or on Venus. But even with taking all this into account and realizing that this is video games, and the reason it wasn't done was because the programmers, they didn't have time. And I understand that. But I do ask you as I do want to mention something that they did take it into account. One of the enemies, more specifically on Mars, the Cabal, wear pressurized suits that replicate their environment because they have a higher gravity world. Thus, their bones are larger. As you can see in the picture, they are very big and very bulky. And this is because the gravity on their planet is supposedly that much. It is theorized, or is talked about among other gamers, at least that I have talked to, 10 times greater because of their bone mass. Now, this obviously was taken into effect by the designers, but not much was able to be done, and we appreciate that they did that. But what about in Assassin's Creed? Assassin's Creed, the gravity doubled in the first game and was about times point, or was increased by another half in the second game. The gravity was not consistent throughout any of it. And this was all supposedly on Earth. We even had structures that we see in Israel. I believe it's Israel. Yes. You can see, of course, more of this free fall fail by the game theory on YouTube. The link will be in the description below. But what am I trying to get at? And why is this so important to game design? Well, you see, as a game design person myself, I have to think about gravity. I have to think of what might happen, or moments like this might happen, where Tiger goes completely out of control and begins to fly. This would not happen on Earth. It shouldn't even happen on this planet, or in this reality. And if we do not inform others, and people are not aware that gravity has an effect, that it's not just our weight, and weight is constant all the way across, that it's the mass that's constant, and that our weight changes from where we go, maybe we might be able to get better things out of it. Again, guys, I thank you for spending your time with me and listening as I talk about gravity on other planets and giving you a few demonstrations. And I look forward to hearing what you guys have to say. Bye.